Notes today are on solving compound inequalities. Last time we defined compound inequalities as two inequalities connected with an and or an or statement. We also focused on graphing those compound inequalities. Today we will solve them and then graph our solution. So we are asked to solve and then graph the solution on the number line. And we are given 5x minus 3 is greater than 7, or 3 minus 2x is greater than or equal to 5. So because we have two inequalities connected with an or sign, we're just going to solve each inequality independently. So we're going to solve this 5x minus 3 is greater than 7. And we'll solve and get a solution for that. We will solve the 3 minus 2x is greater than or equal to 5, and then we'll just bring down the or sign. So we've solved lots of inequalities like this one here. The first thing we need to do on both sides is to add 3. So we add 3 to both sides, giving us 5x is greater than 10. Divide both sides by 5. Gives us x is greater than 2. And then we're going to solve this one over here. We need to start by subtracting 3. We've got positive 3 out there. So we subtract 3. When you bring down the 2x, don't forget to bring down the minus sign with the 2x. 5 minus 3 is 2. We divide both sides by negative 2. Giving us negative 1. Don't forget, if you divide both sides by a negative number, we need to flip our inequality around. And don't just circle this and circle this, because an or statement and an and statement are different things. So if there was an or in the problem, there should be an or in our answer. Our answer is x is greater than 2, or x is less than or equal to negative 1. We move over to our graph. And for an or statement, we said that either one of these could be true. So x is greater than 2, any x values greater than 2 make the inequality, the compound inequality, true. So x needs to be, or could be, greater than 2. So we shade everything greater than 2, open circle on 2, shaded to the right. Or it's possible that x could be less than or equal to negative 1. Those also make the inequality true. So close circle at negative 1 and shaded to the left. We just solve each one as though it's its own problem. We bring down our or, and then we graph like we did last class. Example 2. Again, asks us to solve the compound inequality, graph our solution on the number line. We have two different inequalities. This time they're connected with an and statement, but we do it the same way. X divided by 2 minus 5 is less than or equal to 3. We want to solve this inequality from the left. Start by adding 5 to both sides. I get x divided by 2. This side gives me 8. I do not flip my inequality when I add. When we divide, we can cancel division by multiplying. We multiply both sides by 2. If I multiply by a positive number, again, I do not flip my inequality. I get x is less than or equal to 16. Our second inequality over here, we add 4 to both sides. And then 4 make 14. I divide by positive 2. I don't flip my inequality there either. Problem said and, my solution should say and. X is less than or equal to 16, and x is greater than or equal to 7. Now we need to graph our solution. For an and, we need both of these things to be true. So we're going to, up above, graph each one individually, and then take a look at where both of them are true, where the overlap of the two are. So I need x to be less than or equal to 16. Less than or equal to 16 would look like that. X also needs to be greater than or equal to 7. Greater than or equal to 7 would look like this. Notice both of them are true in the middle, in between. So I need a closed circle on the 7, a closed circle on the 16, and for an and statement, I shade in where they're both true. They're both true in between 7 and 16. Example 3, last time we also looked at compound inequalities that looked like this, where we just have something in the middle of the two inequalities. This, remember, is an and statement, even though it doesn't have the word and in there. And we're going to take a look at this problem, and we're going to do it 2 different ways. I don't care which way you do it, as long as you can get the correct answer. The first way we're going to do it is we're going to set it up similar to how we did the last one. We said this is an and statement. So the first thing we're going to do, we're going to cover up this part here, and we're just going to recopy this down here. So we're going to put 5 is less than 3x minus 7. I would use my hand, just cover up the inequality to the right here, and just copy down that part. We said that if it's written as one line, it is always an and statement. So we're going to put the word and in there. And then we're going to cover up the left part of the inequality over here. And we're going to copy that part down. 3x minus 7 is less than or equal to 14. Basically, I am taking it from the way it was written here as one line, and I'm setting it up as 2 separate inequalities. That's what examples 1 and 2 look like. This is what we're kind of familiar with. So now we know how to solve it. And again, we do that simply by covering up this inequality, copying that part down, cover up this inequality, copy that part down, and make sure we put the word and in between. And it will always be an and if it's written like this. And now we do it exactly the same way we did example 2. We solve each individual inequality. This one, add 7. Divide by 3. Make sure we put and in our solution. Oh, what happened there? That's doing something crazy. Anyway, x is greater than 4 and x is less than or equal to 7. To graph. I need x to be bigger than the 4. X is bigger than the 4 would look like this. I need x to be smaller than the 7 would look like this. Notice my overlap is in between those two things. In the middle here. That is one way that you can do this problem. If you do it this way, notice it's very similar to doing it like this. It does take a little bit longer. There's actually another way we can do it. Either way works fine. Let's redo example 3. And we're going to do it a second time, just a slightly different way. What you want to do is you want to look at what's in the middle here, 3x minus 7. And that is what we're trying to get. That is where we're trying to get x by itself. So think about if I had 3 times x minus 7, the first thing I need to undo is the minus 7. We undo minus 7 by adding 7. I am adding 7 to the middle part of the inequality. If I add 7 to the middle, I not only need to do it on this side of this inequality symbol, but I also need to do it on this side of this inequality symbol. Basically, anything you do to the middle, you need to do to both parts of the outside as well. Those cancel. 14 and 7 make 21. I bring down my inequality. 5 and 7 make 12. And divide both sides by 3. Again, if I divide the middle by 3, I have to divide all of the outsides of the inequality by 3 as well. This is a fine way to write your answer. That means the same thing as the answer we wrote on the previous one. Notice I've got an open circle at 4, a closed circle at 7, and my x needs to be between 4 and 7. It needs to be bigger than 4, but smaller than 7. And again, my shading's in between. I get the same answer, I get the same graph, no matter which way you do it. I don't care which way you do it, as long as you can get the correct answer, correct graph. One more problem, example 4. Example 4 looks pretty similar to the last one. We've got a compound inequality. It's all written as one line. I am going to do this one the second way that we did it. It's a little bit faster. It's probably a more common way of doing it. If you prefer to cover up each part of the inequality and rewrite it both times and put the word "and" in between, by all means, do it that way. So taking a look at what's happening to our what's happening to our x, we're adding 6 to it, and then we are dividing by -3. So the first thing I need to undo is that divided by -3. I can undo division by multiplying times -3. Those will cancel. If I multiply the middle by -3, I have to multiply this side by -3, and I also have to multiply this side of the inequality by -3. These times -3 divided by -3 cancels. I get x plus 6. 4 times -3 is -12. Negative times negative is +6. And I multiplied times a negative. When I multiply times a negative, I have to flip my inequalities. I flip that one, and I also flip this one. Next thing we're going to do is subtract 6. Again, if I do it to the middle, I have to do it over here and this side of the inequality as well. Subtracting, I don't flip my inequality. -12 minus 6 is -18. 6 minus 6 is 0. This is a fine answer to have. If you were in my class, I would take that as an answer. Usually, though, inequalities are written least to greatest, and the -18 is the smaller of the -18 and 0. So if this is a multiple choice question, the answer probably would not look like this. It would look like this. They would put the -18 first and the 0 at the end. Notice x is bigger than the -18 or equal to. and 0 is bigger than the x. Either of those answers are fine. If you get this and it's a multiple choice question, and that's not an answer choice, but this is, just make sure you understand that those are the same thing. To go from -18 to 0, I'm not going to be able to count by ones here. So we need to make sure we have -18 on there somewhere. Put -18 here and count by twos, maybe. Hopefully that'll do it. Just barely. I need an open circle at 0. I need a closed circle at -18. And I need x to be between those two things. That is a wrap for today's notes. I'll see you next time.